Hello, this is the third video in a row today because you guys are sending in some brilliant hard questions. This is one that I've actually done the work solutions for. So if you go on Google Classroom, you'll find this past paper done if you go to classwork. That's if you're watching in 2025. But I'm going to go through it anyway because I think there's heaps of good stuff in here for both differentiation and integration. And this one is well worth making sure you've worked through fully. You can see that it's a 10-mark question with 2 easy marks. And as is often the case, those first 2 marks lead into the second part of the question. And the examiners noted in their report that very few students actually could get to grips with part 10A. Now, that kind of surprised me because 10A is a level 3 calculus achieved level integration question. So I don't really get what that's about. In the second part, you have to just be very careful not to screw up with your signs and with evaluating the constant. But again, if you've got your basics down, it's not too bad. So let's have a look at what we've got. In the first part, we have to write, we have to change y equals sec cubed theta into this, and then we have to show that this is true. All right, let's just pop down here lower on the screen. So we've got y is equal to sec cubed theta, which is equal to 1 over cosine cubed theta, which we're going to write straight away as cos theta to the power of -3. And that means that dy by dx will equal -3 cosine of theta to the power of -4 times the derivative of the inside function, which is negative sine theta. Okay, now cleaning that up gives me 3 sine theta over cos to the 4 theta, which is 3 sine theta sec theta to the power of 4 as required. So there we go, that's the first part done. Now we should be looking that we're going to use that in here. Right, so we've got a differential equation. Obviously we're going to have to separate the variables first because that's actually all we know how to do at this stage. And we're given one piece of information about the value of x when theta is pi on 3. And then we have to find the value of cosine of theta when x is equal to 0. We're not looking for an exact value. We need to do 3 significant figures. For those of you that are getting up close towards perfect marks, can you be really careful that you do make sure you do the right number of significant figures? And a few of you are not rounding at all and writing down like 8 decimal places, which is just a total waste of time. Okay, let's go. So we've got x squared plus 9 times sine theta d theta by dx is equal to x plus 3 cosine to the power of 4 theta. Right, I want you to pause the video and go right through to where you get a plus c. Don't worry about trying to write theta as the subject. It's fine to leave this one with a bit of trig stuff around it. Okay, well, when we separate the variables, we should get sine theta over cos to the power of 4 theta. Let's just write that out properly. And we get x plus 3 over x squared plus 9 dx. Right, now one thing that quite a few of you are doing in your exams is that you were just writing that and then magically integrating. Please, can you put in an integral sign to make it proper? So there we go. Off we go with the left-hand side, and you can see that that left-hand side is is incredibly close to what we had in that first part. So looking back to that first part, we know that on the left-hand side, we've got 1/3 of sec theta to the power of 3. And here, if we start looking for patterns in here, we can see that we've got x squared plus 9 in the denominator, and the derivative of that is 2x. Now, we've got nearly 2x sitting here. And then if we see the plus 3, you should be noticing that we've got something with a tan inverse going on. So we're going to split this up into 2 parts. I'm going to get x over x squared plus 9 plus 3 over x squared plus 9. Now, both of those at this stage of the year should feel like really easy integrals. The first one is going to be 1/2 the natural log of x squared plus 9. And now for this next one, I'm going to rewrite it so that I've got a 1 plus pattern in here, just to be really careful with the constant. So we'll pull out that 9 as a common factor. We're going to have 1 plus x squared on 9. Now we did something a lot like that when we did all those early binomial expansions in term 1. Right, a couple of things to clean up here. Obviously x squared plus 9 is positive, so it's fine for me now to drop the absolute values around there. And in here, we can simplify that fraction down to 1/3, so it's going to be plus 1/3 of, leave a gap, tan inverse of x over 3. When I differentiate this though, I'm going to get 1/3 coming out, and I need to undo that with the reciprocal, which is 3. Okay, so just go over that, and then we need a plus c on the end. Let's go over that more slowly. Some of you will be able to speed up here. This x squared on 9 can be rewritten as x on 3 squared, right? So that's my clue for what my tan inverse is of. So it's tan inverse of x on 3. By the chain rule, when I differentiate this, I will get a times by 1/3. To undo that, I'm multiplying by 3. And because I had 3 over 9, that's where that 1/3 is coming from. All right, so that's all of my integration done. Now what we've got to do is just clean things up a bit. We've got 1/3 sec cubed of theta is equal to 1/2 times the log of x squared plus 9 plus tan inverse of x on 3 plus c. Now it's time to substitute in what we were given. So let's see what that was. We were told, let me just turn the page, when theta is pi on 3, x is equal to 3. So let's just draw our special triangle. 1, root 3, 2. Here's pi on 3. So sec of pi on 3 is the hypotenuse over the adjacent, so it's going to be 2 over 1, which is just 2. Before I do anything else though, I think I'm going to times everything through by 3, just to clean it up. You don't have to do that, but that's what I did. So we get sec cubed of theta is equal to 3 over 2 Remember that when I times through by 3, that's c, it's fine at this stage to just replace it with c, or you could call it c dash, whatever you want. Right, 2 cubed is 8, so we have 8 is equal to 3 over 2 times the natural log of 9 plus 9, so natural log of 18, plus 3 times the angle whose tan is 3 over 3, right, which is 1 plus c. Now, you shouldn't even need a special triangle to tell you that this is pi on 4. So it's going to be 3 pi on 4 plus c. So that's all quite messy, but that's okay. It's not too hard. So we've got sec cubed of theta is equal to 3 over 2 ln of x squared plus 9 plus 3 tan inverse of x on 3. And now I need my plus c. So plus c will be plus 8 minus 3 on 2 log of 18 minus 3 pi on 4. Right, so pretty mucky, almost solution. The last thing we've got to do is to say what happens when x is equal to 0. We need to get, I think we're asked for cos of theta, not theta. Let's check that. Yep, find the value of cos of theta when x is equal to 0. Okay, so it's just another substitution exercise. We've got 1 over cos theta cubed is equal to 3 over 2 log of 9 plus 3 times the angle whose tan is 0 plus 8. What a mess. Minus 3 over 2 log of 18 minus 3 pi on 4. I can do some cleanups in here. We get 3 over 2 log of 9 over 18. That's that one dealt with, and that one. This is 0. because the angle whose tan is 0 plus 8 minus 3 pi on 4. We're getting close to bunging this into our calculator. But just one more line there. Okay, and then I got for this, when I did it, 4.604085. Yuck, no nice exact values. So cos of theta is going to be the cube root of 1 over all of that. And for that I got 0.601108. I want to have 3 significant figures, so it's going to be 0.601 to 3 sig fig. All right, thank you, Linus, for sending in that great question. Keep them coming, and I will do some more later on tonight.